So in this video, we're going to talk about precipitation reactions. So now precipitation reactions is a type of chemical reaction in which that it's a process in which an insoluble solid called a precipitant, all right, forms when the reactants are combined in the aqueous solution. So basically, typically what takes place is that you will have two aqueous solutions, all right, so you will have an aqueous solution that will react with another aqueous solution. And what's going to happen is that you will typically form some type of solid. So this solid is insoluble. It will not dissolve in water. And so this solid here is what we call the precipitate. All right. So that's the whole idea of a precipitation reaction. Now, whether a precipitation reaction will occur on mixing aqueous solutions of two ionic compounds, it really just kind of depends on the solubilities of the potential product. So what do I mean by solubility? Solubility is the amount of a compound that would dissolve in a given amount of solvent at a given temperature. So solubility is temperature dependent, but it's all about how well can something dissolve in water, right? And so a substance that has high solubility, right? That simply means that plenty of it will dissolve in water or dissolve in whatever solvent we're talking about. In this case, since it's aqueous solutions, we're going to just talk about water. So like, for example, sodium chloride has high solubility, all right? So a lot of it will dissolve in water in a given amount of water at a given temperature, okay? And now if a substance has low solubility, this simply means very little or to none will actually dissolve. And so in this case, when we're talking about precipitant reactions or precipitation reactions, then the substance that is being formed, that solid, has low or to no solubility. All right, and this is the reason why you can actually see the solid in water. Okay, so now there are general trends of types of compounds that we typically see that have low solubility or that will most likely precipitate. Okay, and so we're going to go through some of the general rules that you should know of the type of compounds that we will most likely see that will precipitate, or most of the type of compounds that we see that will most likely dissolve in water. So a compound is soluble, so that means it won't precipitate if it contains one of the following cations. So for example, if the compound contains any of the alkali metals, right? So either lithium ion, sodium ion, potassium ion, rubidium ion, or cesium ion, that compound will be soluble. Okay, if the compound consists of ammonium, the polyatomic cation ammonium, all right, it's going to be soluble. So let's just kind of go through just some examples so that we can see exactly what we're talking about. So like, for example, NaCl will dissolve in water. All right, if you have a chemical reaction and the product makes NaCl, it's going to be aqueous. It's going to be soluble. Why? We have the sodium ion here. If you have for example, lithium nitrate, all right, the product of a chemical reaction is lithium nitrate. It's going to be aqueous. Why? Because you have a lithium ion within this compound. If you have a chemical reaction and the product is, for example, ammonium bromide, all right, you could correctly predict that it's going to be aqueous because this product consists of the ammonium ion. So anytime you have any of these type of ions, either a group 1 cation or the ammonium ion, then you could rightly assume that it's going to dissolve in water. And so these products is not going to be a precipitant. It's not going to be insoluble. All right, it's going to dissolve in water. Now, secondly, a compound is probably soluble if it contains one of the following anions, right? So if the anions are halides, so meaning it's just charged halogens, right? Halogens that are ions, right? Such as chloride, bromide, and iodine, then it's most likely going to be soluble in water. So it's not going to form a precipitant, except, and a big exception here, all right, except when bonded to silver, mercury, or lead ions. Okay, and so for example, let's um, talk some examples here. So for example, if you have CaCl2, then you could rightly assume that this is going to be soluble because you have these chlorides here, right? If you have something like, for example, let's see, LiI, right? This is going to be soluble, right? Because you have the iodide, you have the halide here, okay? But then if you have something like AgBr, all right, well, you're thinking, okay, well, I have this halide here, but the halide is actually bonded to the silver, and this silver is one of our big exceptions. So this will be what we say is insoluble, or it's going to form a precipitant, all right? If this is a product, all right? So this is something that you could rightfully assume in a chemical equation. If they were to ask you, hey, what's most likely the state of matter, this is going to be, it's most likely going to be a precipitant. It's going to be a solid, all right? And so you'll write a solid to show that it's insoluble, okay? And so another example, if you have like PbCl2, right? You're looking at CO2. Well, here's our halide, but the halide is bonded to a lead. This lead plus 2, and we know that lead plus 2 is just one of the exceptions. So it's going to be insoluble, all right? It's going to precipitate, all right? We're going to have a precipitant in this case. We're going to have a solid in this chemical reaction. You will find a solid form within the solution, okay? Now, lastly, if we're looking here on the bottom side, we're looking at now polyatomic ions or anions that will that are soluble in water. So that means it will not create a solid. So we have nitrates here. So anything with nitrate is soluble. Anything with a perchlorate is soluble. Anything with an acetate is soluble. And then sulfate, but then it comes with some exceptions with sulfate. So if you have like barium sulfate, it's going to be a solid. If it's going to be mercury 2 sulfate, it's going to be a solid. If it's lead 2 sulfate, it's going to be a solid, because these three are your exceptions. And so what's going to happen is that it's going to precipitate itself out. Okay, so just make sure that you know and are aware of these chemicals, aware and understand the patterns. Okay, and so here's an example problem, right? So let's just say that we have this reaction that's taking place. So we have CdCl2, all right, reacts with ammonium sulfide to form, all right, cadmium 2 sulfide plus ammonium chloride. So I went ahead and balanced these out for you. Okay, so now what I will probably ask you is, okay, well, based off the solubility rules, all right, tell me what are the state of matter would you expect these in, okay, especially your products, right? And if you were to mix two aqueous solutions, so let me just make that clear. So if you were to mix two aqueous solutions, all right, an aqueous solution of cadmium 2 chloride and the aqueous solution of ammonium sulfide, what do you expect your products to be? All right, so you need to kind of go back and think about the solubility rules, right? And so let's kind of start off with this one here. So let's see what we got. So we noticed we got ammonium, all right? And remember we went back and we said that anytime you have an ammonium ion, and we have a chloride ion, but anytime you have ammonium ion, then we see that this is going to be an aqueous solution, all right? And so for this one, I'm going to write AQ, because the fact that I have ammonium, which is any compounds that have ammonium, are going to be aqueous. All right. Now, if you look at this other example, this cadmium sulfide, really, All right, this cadmium sulfide, we haven't talked about it. I mean, we only talked about those that most likely will be soluble. And so cadmium sulfide will be one of the ones outside of those rules. And so because it's outside of those rules, and that means it will not be soluble. It will be a precipitant. So we will form a solid. So I'm going to write an S here, okay? And then obviously, then we could just test the chemical reaction to see exactly if this is something that we will actually really see, all right? And so this is how you use the solubility rules, and it allows you to predict what most likely going to be the state of matter of your products if you're mixing two ionic compound solutions.